Okay, so here are some examples for section 1.2, and if you watch the other videos, you'll have much more thorough explanation of some of this stuff, but here are the examples that I would normally do in class. So the first one is really just an introduction to functions, to see if you remember what the definition is for a function. So I'm asking you to determine if this set of ordered pairs defines a function or not. And the basic thing to look for is if you see any repeated x values. So this one has all different x values, so this is a function. If you see a repeated x value or a repeated input, that would indicate something that is not a function, and that fails the definition for a function. And I'll say more about that in a little bit when we get to the vertical line test. So the first one is a function. I wouldn't try to trick you on the first one. The second one, and again, all I'm going to ask you to do to try to remember for functions, the basic definition is you can't have any repeated inputs. So this one is not a function, the second one. It's not a function because 1 corresponds to a 2, and 1 also corresponds to a 4. See how 1 is paired up with a 2, 1 is also paired up with a 4. So that indicates something that is not a function. That fails the definition. Okay, so part C, again, this one fails. That looks like a typo. I just typed the same exact thing twice. So that's not a function. Then the fourth one there, this one looks okay. All the x values are different. Sometimes someone will say no because those 2's show up twice. But this is actually a function. It's not a one-to-one function, which is more something in chapter 5, but this is a function because all of the x values are different. Okay, so for the next couple examples, and these are probably the most important from this section, is how to deal with evaluating functions. And what I would say in class is really all this notation is telling you to do is substitute. This 3 is getting substituted in for your x. Now, these first ones are really as simple as they get. You can use a calculator for it. You can type it in just like I wrote it if you want. You can just type that right in. So usually I try to do it in my head. 3 squared is 9 times 2. This is 18 minus 9. So the final value is a 9. So you'll notice that the input is a 3, the input is an integer, and the output is a 9, is also an integer. And that's all there is to that one. Here's another easy one. We're substituting in a -2 for our x value. And again, you may use a calculator to double check, but this is 4 times 2. This is 8 plus 6, it looks like. So this is going to be a 14. Now we get to something that's a little bit more difficult. For part C here, I'm asking you to substitute in a 2x, f of 2x, or a 4x, rather. And you notice I pretty much always use parentheses for this. That's the way I show my work. But now we have to square 4x and then times it by 2. Well, from last week's assignment, from the just-in-time review, we know that 4x quantity squared is 16x squared. And then reducing that, times it by 2, gives us 32x squared. And this is just 12x. So this problem has an algebraic expression for the solution. It is not just an integer. It's not just a number because our input, remember our input was an expression, a monomial. So our output is an algebraic expression as well. Okay, part D, I'm going to have to erase some of this. I didn't plan the spacing too well. But for part D, we're substituting in a negative x. So you got to be careful on your signs. It's typically the biggest mistake in algebra is just sign mistakes, and I make them too sometimes. I'm not perfect, but negative x squared, this expression right here, is really just going to be negative x times negative x, which is x squared, which is where I got this from. And then this negative times that negative comes out to be a positive 3x. Okay, part E I have substituting in here just an x squared. So we have to square x squared. Well, that's x to the fourth. So what I'm trying to say is this part right here is going to be 2x to the fourth. You don't have to factor. You don't have to solve. I see that a lot on tests in the past and homework and stuff. All you have to do when you evaluate a function is substitute and simplify. So whenever you evaluate, you just have to substitute and simplify. And here's another similar one. We need to square negative 3x squared. Well, negative 3x squared is going to be 9x to the fourth, and this is just 9x squared over there on the right. So this final answer will be 18x to the fourth plus 9x squared. All right, now the hardest one here, this is, I think, the hardest one I have in all my examples for this section. We have to substitute in t minus 2 for our value of x. Well, t minus 2 squared really means to times it by itself. So what I did there on that first step is this expression right here got changed into t minus 2 times t minus 2. Now I'm going to FOIL or multiply these binomials, whatever you want to call it. T times 2 is t squared. T times negative 2 is negative 2t. Got another negative 2t. And then negative 2 times negative 2 is positive 4. And I'm not going to try to do too much in one step. I don't want to confuse you too quickly here. But so I'll just leave it at that. Now I'm going to distribute. And then the last step will be to combine like terms. Now there's other ways to do this problem, of course. You get the same answer, but it's not going to be much faster. So I'm going to distribute there, distributing that 2, distributing the 3. Now, combining like terms for our final answer. Here's my final answer. 2t squared. There's no like terms for that. But the t's, we got a t, we got a negative 4t, we got negative 4t, negative 3t. So that's going to be negative 11t. And you have to excuse the noise. That's my cat. So, and then plus 14, the constants. Okay, so that's the end of example 2. And again, I think that's the toughest one I have on here. Now, the next one, example 3, is really similar to that. So I think I'll do the rest of these in part 2.